All right, this is lesson 11.4, and we are going to be factoring some polynomials, and we're going to be pulling out a monomial from that. And so the lesson's called Common Monomial Factoring. Now, it's been a little bit since we've done just regular factoring, so we want to talk a little bit about that. So you can find your definitions here. We're going to jump right in. So we want to list all the factors of 49x to the third. Now, let's start with just 49 in general. List all the factors. Now, factors are things that multiply into 49 evenly. So you could do 1 times 49. So 1 is a factor and 49 is a factor because they're numbers that multiply. And the only other one that you can do is 7 times 7. Now, when we list factors, we don't repeat something if it shows up more than once here. So 7 is also a factor. Now, that's just of 49. So those will also be factors of 49x to the third, and I'll show you how in a second. So just the whole numbers is part of it, but we have to account for the x. So if we had 49x to the third, let's say I pulled out a 7. 7 times something can give me this. 7 times 7x to the third. If I multiply these together, I get this. I could even take a 7x out, and we'll get to that in a second. 7x times, I'll put times as a dot so we don't get confused with the x there. How would I get to here? Well, it'd still be times 7, and it'd be another x. To get to 3, I've got 1 here, I'd have to put a 2 here. Okay, so these are all factors of this. So we're going to break it up into all these pieces. So we're going to have a 7x, a 7x squared, and even a 7x to the third. You can see it right there. 7x to the third was a factor. Something that you could multiply by something else to create 49x to the third. And basically what's going to happen is these are all going to be the same for each one of these numbers. So you're going to have the 49x, you're going to have 49x squared, and 49x to the third. And you're also going to have with the 1 in front, so it's going to be x squared, and x to the third. So again, all of these could be multiplied by one of the other factors we see here to create 49x to the third. So if I just had x, for example, what would I multiply x by to create 49x to the third? It'd be 49x squared. But x can be multiplied by something, a whole number coefficient, to create this. So these are all the factors. All of these could be multiplied by something to create this. Now, it seems like, whoa, that's a lot of different ones. How am I going to remember all that? But you basically start with the coefficient, 1, 7, 49. Those are the only factors. And then you're going to take whatever the power is here, and you can break it into single pieces. So it could be just an x, x to the second, x to the third, all the way up to whatever power it happens to be. All right, so that was breaking apart one single thing. Now we're going to find the greatest common factor of 6xy squared and 18y. So when it says find the greatest common factor, we're going to factor both of these out like we just did, and then we're going to look, and we're kind of prepping for what's coming next. We're going to look and see which one they have in common. So let's start just here, 6xy squared. We know we can break 6 into a 1 and a 6 and a 2 and a 3 because 2 times 3 is 6. And then each one of those could have an x, it could have just a y, it could have just a y squared, it could have an xy. Okay, we're not going to list all of that part out right now. Let's just start with the numbers. And the 18y could be a 1 and 18. It can be a 3 times 6. It can be a 9 times 2. Now they want the greatest common factor. So if you take a look at all of these, the biggest number that fits into both of these is 6. And now if we're going to go ahead and take a look at the variables, all right, any of these, so remember we could break this into a 3x and a 3y and a 3y squared, even a 3xy squared, all the different combinations from here. But between these two, the only ones they're going to have in common are the y's. Because any of these factors over here with an x isn't going to match one of these over here because there is no x. And any over here with a y squared is not going to match any one of these. So we already know the greatest common factor, the coefficient of it, is going to be a 6. And when we take a look, we know y is going to be a part of this. If I said y squared, it wouldn't work for this one. It's too big. But if I just say y, that fits into this and into this. 6y times something to create this would be a 1xy. Because 6y, the y's ends up squared. Here's the x. Okay, so I can multiply 6y and create this. I can also multiply 6y by something to create 18y. It's just 3. 6y times 3 is 18y. So this is the greatest common factor. Okay, it's the greatest term that can be multiplied into both of these evenly. So why did we just spend time doing that? Because if we factor a binomial here, we're looking for the greatest common factor, the biggest number I can pull out of this. Now, we've done factoring before with just the whole number, so we should be pretty good at that, or at least it should come back fast. All we're adding here now is the variable part. We're going to pull out a variable. So it's backwards distributing, basically. So we're going to have something times something in parentheses, and it's going to equal this, 6xy squared plus 18y. So we're going to be multiplying something and it creates 6xy squared. We're going to be multiplying something and creating 18y. So we're thinking backwards. So what we want to do is pull out the biggest number that fits into both coefficients. And we already did the work up here. That's going to be 6. And we also want to pull out whatever variables we can from both terms. Can't pull out an x because it's not in both terms. We can pull out a y, and you want to pull out as many as you can in terms of the powers. But we just talked about 1 is the most we can take out. Can't take out 2 because this one doesn't have 2. So we're using this greatest common factor as what we're going to factor out. And now we just have to figure out what goes in here. Now we just talked about it up here. What am I multiplying to create this 6xy squared? Well, it's a 1. And the y is going to have another y here to make y squared, but an x has to come in as well. And this is just going back to our thinking up here. Plus, what am I multiplying 6y by to get 18y? 3. So if this overcomplicated things for you here, let's go back to here. We're going to get the same answer. But I look at this and I go, okay, I'm going to pull a 6 out. And I look, okay, I can also pull a y out. And now, again, I'm just walking through this process. How do I get back to here? 6 times 1, I need an x, and I need another y to make y squared. Okay, I pulled the 6 out. I need a 3, and I've already got the y. I don't want to add another y to get y squared. I'm good. Okay, so I factored that out. How about a trinomial? Well, first of all, there's no x on this one. So I cannot pull an x out of this because it has to, whatever you pull out has to be in every single term. So I'm only going to be pulling out a coefficient here. What number goes into 6, 12, and 3? The biggest number is 3. Now 6 goes into 6 and 12, but it's too big for 3. So you got to find one that works for all of them. So we've pulled the 3 out here. And so what am I multiplying 3 by to get back to here? Well, it's going to have to be a 2 to create the 6, and it's going to have to be an x squared. 3 times 2x squared gets me back to this. Now what about here? I must be multiplying by a positive 4, and if I want that x to show up, it's got to be here. And what am I multiplying to create a 3? That would be a 1 with no variable. 3 times 1 would be 3. So I have factored that out. So it's, again, like backwards distributing. But we have to deal with the variables now, which we didn't have to before. All right, and we're going to do one more of these. We have to look at all three of these and figure out what's the biggest number that fits into all of them. So sometimes I think the best strategy is to take the smallest number, which here is 8 out of the 12 and the 20, not thinking about positives and negatives, just the actual numbers, and say, does that number fit into the others? Because sometimes it will, just like the 3 just did on the other page. But it doesn't here. 8 doesn't go evenly into 12 or 20. So now I got to start, and again, I think the easiest way to do this is to start with the smallest number. Because if you start working with the big number, you might say, oh, well, 10 times 2 is 20, but 10's never going to fit into 8. So start with your small numbers, and then you don't deal with those numbers that are too big. So obviously, I think with 8, we think 4 and 2, and 4 should be setting off like a little alarm in your head. You're like, oh yeah, 4 fits into all of these. So 4 is going to be part of what I pull out. I'm going to form another trinomial in here with what I'm multiplying 4 by to create this, but there is more in common than just the 4 when we look. All three of these terms have an a in it. They don't all have a b, so I cannot factor out a b, but I can factor out an a. There's an a that goes into every single one. I cannot factor out more than one a because this one only has 1. Okay, so even though this has 5 and this has 3, this one only has 1, so the most I can take out or factor out is 1. All right, so now I'm going to think backwards. What am I multiplying 4a by to create this? So it's a 5 to get the 20, and a to the third, it must have been a to the second. What about here? To get to the 8, it's a 2, and I can't add another a because then I'd end up at a squared, so it is just 2. Here, this would be a minus still to create this, and it's times 3 with that 12. Now, I already have 1a here, so that means I only have 4 here, so when they get put together, it's 5. And this b squared has to be attached here to show up there. And just like a lot of things that we've done before, you can always now double check yourself. Multiply, 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 and make sure we get this, and we're good. All right, last one. Now, we're going to use this skill to help us cancel something here and simplify this. So we know that when we have things being multiplied, so for example, let's say we have 3x over x. We know that these x's will cancel each other out, and we're just left with 3. We also could say, well, if I have 3x over 3, well, the 3's will cancel, and I'm left with x. And sometimes there's other things left over on the bottom. Now, when we can't do that is we can't do x plus 3 and have a 3 here and cancel. That does not work. Cannot do that. Okay, it's only when you have products, things being multiplied. So when I look right here, I can't just start canceling here because I have 2 terms here. This is a binomial. So what I want to do is I actually want to turn this into a product. So notice up here, I had adding and subtracting. I had a trinomial, separate terms. But when I factored something out, I created a product where now if one of these 2 whole things that are being multiplied together showed up on the bottom, I could cancel them out. So what we're going to do is we're going to try and simplify this by factoring the top, and there's the hint, factor the numerator. And what I want is to factor something out that will cancel with the bottom. So what I want to have is an m out front. I want m times something because then that m will cancel with this m and help me simplify this fraction. Okay, so this is all going to be over m. Now, as I look at this, I could factor out a 2. Right, 4 is not going to work because 4 doesn't go evenly into 22. But I could factor out a 2. And I could also factor out an m. There's an m in both of these. So I can do this. And that's okay. All right. I don't need to only factor out the m. Now, for simplifying purposes, it's fine if you did that. So let's actually do this twice. Let's factor out just an m. And then look at the results and see what we get. So here, if I took a 2m out, what am I multiplying 2m by to get to here? So it's 2 times 11 to get 22. And I've already got the m. So I can't add another one, otherwise it'd be squared. And to get to the 4, it'd be 2 times 2. Now I do have an m squared, so it was m times another m. We could factor it out this way as well, with just an m coming out. So m times something gave me 22m. That'd be 22. And then m times something got me this. So they're going to be the 4 there. And m became m squared. So there was an m. So in this case, the m's will cancel. Now that I have a product, two things being multiplied, I can cancel. And I'm left with 22 plus 4m. Okay, simplified. And up here, these m's, now these are technically three things being multiplied. 2 times m times this whole quantity here. So since they're all a product, it's being multiplied, these m's can cancel. And I'm left with 2 times 11 plus 2m. And look at these two now. These are actually equal to each other. 2 times 11 is 22, and 2 times 2m is 4m. And we'll get to a point where fully simplified is actually going to be completely factored as well. So these are equal to each other, because if I actually factored this and I said, what goes into both of these? Well, it'd be 2. How do I get to 22? It's 11. How do I get to 4? It's 2, and I need the m. Oh, look, that's the same as this. So they are equivalent to each other. One's just factored and one is not. So really what we're looking for is to create a product up here by factoring to create something that cancels. So you can kind of cheat on these. You can look at the bottom and say, well, if this is going to cancel, that means I must be pulling an m out of that. So it'll give you a hint. We're going to practice a bunch of these, and you'll kind of find which strategy is going to work best for you.